Hi everyone, welcome to day 3 of AI/ML roadmap series, and today we will be discussing Python operators. Okay, so uh, I hope you guys remember that in the previous session we discussed about the number data type and the Boolean data type, and now we will be discussing Python operators. Okay, so operators in Python are symbols used to perform operations on variables and values. Okay, so there are different type of operators. I think we have 7 type of operators. Don't worry, they might look too much, but they are pretty simple, and it's something that we do end up using in our daily life. So they'll be quick to understand. Okay, so first is arithmetic operators. In this we have addition, subtraction, multiplication, division, floor division, modulus, exponent. So these are something that we have been using in our academic mathematics. Second is comparison operator. So whenever we need to compare two values, we use comparison operator. Okay, uh, equals to, not equal to, greater than, less than, greater than equal to, and less than equal to. Good. So we have like 6 comparison operators. Next we have logical operators, which is add, or not, and, or, and not. So logical operators, I think a lot of you guys have learned about logic gates in your mathematics, or even in physics as well. So this is something we have in Python as well. So basically it used to combine Boolean expressions, and there is a truth table, a very simple truth table that we will discuss later on once we'll start working uh, with the logical operators. Okay, next is the assignment operator. So whenever we do something like a equals to 5, that means we are assigning the value of 5 to the variable a. This equals to sign that you can see is called as an assignment operator. Okay, so assignment operators are basically used to assign or update a variable value. For example, equals to 5, we are assigning the value of 5 to a variable a, and this a equals to a plus equals to 3, this is we are updating the value of a by 3. Okay, so this can, the same can be written as a equals to a plus 3. Yeah. Next we have identity operators. Identity operators basically is used to compare object identity. So let's say if I say 6 is 6, so that should be true, right? And if I say 6 is not 7, which is not, right, so it should be false. Okay, membership operators, this is something that we use to check something. For example, if there is a class of 10 students, and if I want to check whether John is part of the class or not, I can simply do like John in the number of students that are there in the class. Okay, so if he is there, I'll get a true boolean. If he is not there, I'll get a false boolean. Okay, similarly, not in, if he is not there, I'll get true. If he is there, I'll get false. Okay, next we have bitwise operators. So bitwise operators are the operators that works on binary numbers. Okay, binary numbers are the numbers that starts with 0 1. So any number that we have um, in, I think any whole number that we have, we can convert it into binary. So we'll discuss it how we can do it. So we have like these operations: bitwise AND, OR, XOR, NOT, left shift, right shift. Okay, so let's start with the first one, which is the arithmetic operators. Okay, so we'll start with very basic. So let's say I have number 1 equals to uh, 16, and a number 2 which is let's say 7. Okay, now we have discussed that these are the arithmetic operations we have. So let's check. So I'm not creating something like num3 equals num plus num2. Okay, I can do this. So then I can do num3, or I can directly do num1 plus num2. Okay, so both should give the same result. The only difference is, okay, yeah, so 16 plus 7 is 23. So both are giving the same response. The only difference is here, if I call this like after, like throughout the workspace, the number the output will be 23. But if this is something, it's not saved anywhere. Okay, but here I have already assigned it to a variable which is num3. But here, but this thing, it is just printing. Okay, I have just outputting the sum of it. It's not getting assigned anywhere. It does not have like num1 plus num2 does not belong to a third integer. Okay, so this is how we use a plus operator. Yeah, next we have minus. Similarly, 16 minus, so num1 plus num2, which is 16 plus 7, is 23. Similarly, num1 minus num2 is 16 minus 7, which should be 9. Oh yeah. Similarly, num1 into num2, num1 divided by num2. So let's check quickly. So 16 into 7, I did not know what is 16 into 7, so I'm just checking 112. Yeah, and if you do want to clarify, you can just simply just verify it as well. Just open any calculator app and just quickly do 16 into 7, and it should be 112. Yeah, makes sense. Similarly, for division, 16 divided by 2 divided by 7, I can tell 7 to the 14, so it should be 2 point something. Yeah, so which makes sense, right? Okay, next operator we talked about is okay, so these are the basic: plus, minus, addition, subtraction, multiplication, division. Okay, next we have modulus. So let's see how it works. Num1 modulo num modulo num okay num2. Yeah, so it will give me, so I'll tell you how. It will give me the remainder. So 16 divided by 7. Okay, so 7 into 2 equals to 14, right? So what is left? 16 minus 14 equals to 2. So 2 is the remainder. Okay, next we'll check for the exponential. So num1 num2, so it should give me num1 to the power num2. Okay, so I don't know what it is, so let me quickly check with the calculator app and make sure that it should be same. So 16, okay, in calculator we don't have the this operation, no worries, but we can assume that it should be correct. So it is going to be something like this. So it's a bigger number. Okay, next we'll check num1 floor division. So I'll tell you what it will give. So if I do this, so it will give me 2. So floor division gives the okay, so yeah, so this is how the floor division works. Okay, Okay, so how floor division works? So it rounds. So for example, if I do 16 by 7, so it should be something 2.28, right? So it will give me the floor value equals to, it should be 2, right? Yeah. Okay, next we have comparison operator. Again, let's take two variables. Let's call them num3 equals to 5, num4 equals to 6 or 10. Okay, so if I'm doing num3 equals to num4, so is 5 equals to 10? No, right? So it should give me false. So 5 not equals to 10, which is true, right? 5 is not same as 10, so it should give me true, right? So let's quickly check it. Yeah. Next is we have print num3 greater than num4, yeah? num3 is less than 4. Okay, so now is 5 greater than 10? No, right? So it should give me false. You know, is 5 less than 10? Yes, so it should give me true. Yeah, so if you see, it works, right? And the last two we have is, so is 5 greater than equals to 10? No, right? Is 10 less than equals to 5? Yeah, true. It should give me true. Okay, let's check one more thing. So if I say print is 5 greater than equals to 5, it should give me true, right? Because it is. And if I say print 5 less than equals to 5, which is also true, है ना? So it should give both as true. Make sense? So this is how we can do comparison. This is how we can do comparison, okay, between two variables. Yeah. So one more thing, here we are doing the comparison between two operators, right? Two variables, right? But what if there are multiple variables as well? For example, let's say somebody say check whether num3 is greater than 3 and less than 5. So what should be the answer? So is 3 num3 is 5, right? So if I do is 3 less than 5, true? But is 5 less than 5? No, right? It should be false. है ना? Let's try one more. Is 3 less than 5? True. Is 5 less than 10? True, right? So it should give me false and true, right? Makes sense. Next we have logical operators. Okay, like we discussed, logical operators are used to combine conditional statements. Okay, so for example, and it will give me true if both the statements are true. Yeah, and similarly or will give me true if any of the statement is true, and not is simply will reverse uh, the result. Okay, so let's quickly check. Let's say a number x is equals to 10. Okay, and we'll see if print x is greater than 0 and x is less than. Okay, yeah, so let's say if I say print x is greater than 0 and x is less than 20. So I have so I have uh, 10, right? 10 is greater than 0, true, and 10 is less than 20, which is also true. So now the both the statements is true. So true and true is true, right? So the answer should be true. Here it says 10 is greater than 0, true, and 10 or 10 is less than 20, which is also true. So true or true should be true, right? Yeah, so let's create a truth table for and. Okay, so if yeah, if the first condition is true and the second condition is true, so output should be true, right? If the first condition is true, second condition is false, then the output will be false. If the first condition is false and the second condition is true, the output will be false. And if both the condition are false, the output would be false, right? Similarly, let's try to test this. Okay, so we have print. Okay, let's try to test it out. So let's say first condition says x is greater than 5 and x is less than 20. Yeah, so x is greater than 10 is greater than 5, true, 10 is less than 20, true, so the output should be true, right? Next we'll create x is greater than 5, right, and x is less than 5. So let's try. So 10 is greater than 5, true, 10 is less than 5, no, right? It should be false, so the answer should be false. Okay, let's try the third condition. Let's say x is less than 5, 10 is less than 5, false, and second is 10 is less than 20, true, so the output should be false, right? Now let's check the last condition, which is saying x is less than 5 and x is greater than 5. Okay, so let's check. 10 is less than 5, false, and 10 is greater than 5, false again, so the output should be false, right? Let's quickly verify it. So first is this one, this is fine, then we have this. Okay, let's quickly add a print statement as well. It says and truth table so that there is no confusion. Okay, so this works, right? Now let's try for or truth table. Okay, or truth table. Okay, so if we have true and true, then the output is true. Yeah, if we have true and false, the output would be true, because at least one is true, right? And similarly, if the first one is true and the second one is true, if the first one is false and the second one is true, the answer should be true. And if both are false, only then it should be false. Yeah, makes sense? Let's give it a try. Similarly, how we created here, we'll create an or truth table. Okay, let's do this. So 10 is greater than 5, true, and 10 is less than 20, like both the condition is true, so the answer should be true, right? Now let's do this, like let's take the same, but only one thing is going to change. Okay, so 10 is greater than 5, true, or okay, let me quickly change these as well. Yeah, okay, so we are discussing this one. So 10 is greater than 5, true, 10 is less than 5, which is false. But in or truth table, we are saying if the first condition is true and even if the second condition is false, the overall value should be true, right? Next is 10 is less than 5, false, or 10 is less than 20, true, right? So the overall value should be true. Yeah. 10 is less than 5, false, or 10 is greater than 5, true, right? Okay, I think we missed somewhere. Okay, so here it should be, this should be something like this. 10 is greater than 15, let's say. So here 10 is greater than 15, false, then the overall answer should be false. Make sense? Yeah, true, 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 false. Okay, then last is the not truth table. It's simple. If the output is true, then if the output is true, then the output is false. If the output is true, then the output is false. Okay, let's quickly. Okay, so here, okay, so we have x is 10 is greater than 5, true, and 10 is less than 20, which is also true, right? So true and true should be true, right? But now we also have a not attached to it, so it will be false ultimately. Okay, second says 10 is greater than 5, true, or 10 is less than 20. Is 10 less than 20? Is true, right? So the, and there will be a true, so the output should be false, right? Yeah. Now let's check for this one. Okay, so 10 is less than 5, false, and 10 is greater than 15, again false. Now we have a and, so the both condition needs to be true, right? So it should be false. Now we have a not flag on top of it, so not of false should be true, right? So the output should be false false true. Makes sense? So this is how you can define the logical operators. Okay, pretty simple, but sometimes it takes time to just grasp it. Okay, so they also, so you know, so right now these things looks very simple because they are eventually, these are something that has you have been using your entire life, so these are pretty simple. But at the same time, when you are building a huge project, these things comes in handy to work through your project efficiently. Okay, okay, okay. Next is identity operators. So identity operators are used to compare the object. Okay, not just whether they are equal, but it checks that whether they are the same object with the same memory location or not. Okay, so for example, let's say I have this list which is x is equal to apple banana and y equals to apple banana. Okay, now if I do print x is z, so it should print 2 z, x is z, it will give me true. Can I show you something? So let's say if I add a variable to, let's say if I add a variable z dot append, let's say cherries. Okay, so, and if I do print z, let's print before and after. Okay, print z. So let's see something. So initially z have apple banana, and after I add one more item to the list, it has apple banana and cherries. Now let's check what would be the value of x. Yeah, so now if you see, the x also has the cherries item, but we did not add cherries to x, we only append cherries to z. So how does it add cherries to z x as well? So when you do something like this, it will create a copy of x here. So whenever you make any change to x, whenever you make any change to z, it will automatically get updated here as well. Okay, so basically they share the same element. Yeah, but if I do the same, let's say if I do the same change to y, let's say I say cherries, and if I say print y, it will add cherries to y, but it won't affect any other because y is a different list and altogether it does not reference x in any way, right? So this is how this works. Okay, okay, okay. Now if I see, if I, let's say if I check whether print x is y, so it should print me no, right? Because these are two different variables that which created two different objects. So if I do this, it should print me false. Let's see whether it does that or not. Yeah, right. And if I do something like print x equals to y, what should it do? So it will be comparing the values, because we have gone through this, right? This is a comparison, assignment comparison operator, so this should print true. Yeah, makes sense. True. So we got the difference between is and equals to. So is compares the object and equals to compares the value. Make sense? I think pretty easy to grasp, but sometimes we get confused. Okay, so don't get confused. If there is an is, that means we are comparing the object. If there is double equals to, we are comparing the values. Okay. Second is not. Similar x is y, so it will print me false, right? It should do that. But if I say x is not y, x is y, false. But now I am doing a not thing on this false, which will change it to true, right? How we have done it with the logical similar, or how we did it with the what's there. Okay, we haven't gone there. Yeah, how we did it with the truth, with the note. Okay, similar. So if I run it, yeah, true and false. Makes sense, right? Okay, I think that's it for the identity operators. Next we have the membership operator, similar to identity operator. So membership operators are used to check whether if a sequence is presented in an object or not. Okay, so in will return true if a sequence with the specified value is present in the object or not. Okay, so for example, let's quickly do that. For example, if I have a list, list one, which has some items. Let's say it has some student's name. Let's say John Doe Will and Mike. Okay, so if I do something like print John in list 1, so does John exist? Yeah, so it will print true. Okay, now if I do if Rambo exists in list 1, so it's not, right? So it should return false. Make sense? Simple. Now if let's check something else as well. If I say print if Joe exists in list or not, let's see what's the answer, right? So it should return false. It's not checking the subset of it, it's checking the entire item. Okay, makes sense? Similarly, not in works. For example, if I say let's take the example, similar it works like a not logic gate. If I say John not in, yeah, so John in list true, but because we have a not gate, it will become false. Yeah, similar here, Rambo in list no, so it should be false, but since we have a not, it will become true. Yeah, and similarly for here, Joe in list no, false, but since we have a not, it will become true. Let's quickly verify it. Yeah, false, true, true. Makes sense? Okay, I think this is with the this is all with the memberships. These are pretty easy ones. Okay, but they get very used. For example, if you are searching through a database, or you are searching through some strings, some lengthy strings, then this in membership operators comes very handy. Okay. Yeah. Okay. Next we'll start with bitwise operators. Okay. So like I said, bitwise operator is used to compare the binary numbers. Okay, so let's quickly do. For example, uh, something I've missed. Okay, yeah. Okay, so let's say if I say print 6, if I say 6 and let's say 3. Okay, so let's see how it works. So for example, this, it is returning me 2. Yeah, let's see how it's working. So if I 6, if I see the decimal of 6 is 0 1 1 0. Okay, so how you want to check? You can simply search somewhere on Google and mention something like convert decimal to convert decimal to what is it, decimal to binary, something like this. You can search on Google or anywhere, you will get the output. Okay, so some for example, I have done this. So any first thing you'll see, for example, I'll put 6 here. So I have got this, right? 1 1 0. Where am I? Yeah, so it should be, let's say let's put it 1 1 0. Next I have is 3. Let's check what would be the binary for 3. It should be 1 1. Okay, it should be 1 1. So I'll write it at something like this. Now we have discussed what is, like, how AND operation works. If each bit is true, then the output is true. So, and in binary we say 1 for true and 0 for false. Okay, makes sense? So now if I am saying this, then what should be the output here? Then what should be the output here? It should be 0 and 1. 0 and 1 should be 0, right? Makes sense? And 1 1 should be 1, and 0 1 should be again 0, right? So it should be 0 1 0. So let's check what is the decimal for this binary. Okay, similar how we did this, we can now convert binary to decimal. Now if I do this, I'll get the decimal as 2, right? Decimal. And if I run it again, so it will give me the output as 2. So this is how the AND bitwise operator work. Yeah. Next, let's check for the OR. Again, for example, I am taking this 6 or 3. Same, 6 is written as same. Let's copy paste it. Sorry. Okay, convert binary to decimal. We'll move a bit quicker. So and yeah, so what is how we are doing OR is each bit to 1 if one of the two bits is 1. Okay, so let's do here. Okay, sorry. Okay, 0 1 1 makes sense. 1 1 1 Make sense? 0 1 should be 1, right? है ना? Make sense? Now we'll check what is 111 called in decimal. So we have this binary and we'll simply convert it. So the answer should be 7. So if I convert this binary to decimal, the answer should be 7. Let's quickly verify it. Yeah, makes sense. Next we have the XOR operator, which says that each bit to 1 if only one of the two bits is 1. Okay, so let's take again the same example. Print 6 to the XOR operator 3. Okay, let's see how it works. 0 1 should be 1, 1 1 should be 0, because it says only one of the two bits is 1, right? And 0 1 should be 1. Let's see the binary for decimal for 0 1s. So it should be 5. Now let's quickly verify it. Yeah. Okay. Next is NOT. Simply similar to the NOT logical gate that we had, and similar we'll do this. Okay, let's say print NOT of 6. So again we'll write the binary of 6 and we will be writing. So let's quickly convert decimal to binary, and the output should be 6, and we'll take the binary in the 16 digits. Okay, so we'll copy paste this here, convert decimal to binary, 16 digits, and now we'll just reverse 1 1 1 1 1 1 1 1 1 1 0 0 and 1, right? Now we'll check this, and binary to decimal, and it should be -7. Yeah, now let's -7, and now let's quickly check the value. Yeah, makes sense, right? That's how you can use the NOT gate. Okay, next is zero fill left shift. Okay, so what it will do, zero fill, it will shift left by pushing zeros in from the right, and let the leftmost bits fall off. Okay, let's quickly verify it. Okay, so for example, let's do for print let's say 3 equals to 2. Okay, so again let's do, if we have 3, let's quickly check the binary of 3. We have this, decimal to binary. Now what we need to do, we need to push 0 in from the right and let the leftmost bit fall off. Okay, so what will happen is this will remain same, 0 0 0 0 0, and this will become 1 1 and 0 and 0. Yeah, now if we check the binary to decimal, so it should be 12, right? So the answer should be 12. Make sense? And for the last bit, from the left and let the rightmost bits fall off. Okay, so let's take similar example. Yeah, and we'll just copy paste this one and this one. Yeah, now it will 0 0 0 0 0, it will 0 become 1, and we have pushed 1, and now we are going to push it again, so it becomes 0. So the output should be 0, right? Let's try one more example so that it's become a little bit more clear. For example, we have print 8 greater than 2. Okay, let's see what is 8 in binary. For example, I have 8 decimal to binary. I have 8. It can be written as this. Okay, makes sense? Yeah, now we will be pushing it, so it becomes 0 0 0 0 0 1 0 0. Then the second push will happen, it will become 0, and this one becomes 1, right? Now if we check what this is called, it should be called 2. Let's verify it. Yeah, it should be called 2. Yeah, and let's quickly run it. 0 and 2. Let's quickly write this one also a similar way so that there is no confusion. Remove 1 from here and add 1 from here. Okay, let's take one more example here as well. So for example, we have, let's take the similar print 8 less than x than equals to 2, right? So we already know 8 is this. Yeah, makes sense? Yeah, so it will become 1, and the second push would be 0, right? Now we'll quickly check the binary value, it should be 32. Let's verify it if it is correct or not, and it is. Okay, makes sense? I know it's a little bit tricky, but I think just give it a little bit time, and it will be much more clearer to you. Please one. Okay, we here what we can do, we can assign or modify the value of the variable. Okay, so let's say I have defined x is equal to 5. If I do print x, it should be 5, right? It's a simple operator. Now if I do x plus equals to 10, and I do print x, so it should be 15, right? Makes sense? Now if Now if I do, so this is how we can write it as it x equals to x plus 10, which is 5 plus 10, which is 15. Yeah. Now if I say x minus equals to 10, so this how I can write x equals to x minus 10, right? Now that what would be the value of x? It should be 15 because we have updated the value of x. So it should be 15 minus 10, it should be 5, right? So here if I print the value of x, it should be 5. Next is x, x into 10. Now the value of, so it can be written as x equals to x into 10. Now the value of x is 5. 5 into 10 equals to 50. So the value here should be 50. Next is x division equals to 10. So it can be written as x equals to x by 10. And we have the value of x equals 50. So 50 by 10 equals to 5.0. And here if you check the type of x, it should be float, right? I will check it, but it should be float. Now we have x, what do we have? We have x percentage equals to, let's say 10. Okay, so it can be written as x equals to x ampersand 10, which is 5 percentage 10. So it gives the remainder, so it should give 5.0. Now do something like, so it should print 5.0. Let's quickly verify it so that we are not making any mistake. Next is x, what do we have? So this can be written as, this is the floor operation. So right now we have 5.0. Let's do one thing, we'll quickly make it an int. So if I print here x, it should be 5, and if I quickly print the type of x, it should be int. Okay, so now I am doing a floor division. So if I do this, so 5, I think it does not matter, but let's do it just for the sake of it. So 5 floor division by 3 equals to, it should be 1, right? It should be 1.8 something, so it should be 1. So if I do print x, it should be 1. Next we have next we have x equals to x exponent equals to 3, let's say. So I have x as 1, because it gave me a floor value. So x equals to 1 to the power 3 should be 3. Let's modify it. X, let's say x equals to 2, right? So 2 to the power 3 should be 2 into 2 into 2 should be 8. Let's quickly verify it. It should be 8. Makes sense. We are done till here. Let's try this as well quickly. Okay. Now the recent value of x is 10 8 sorry. Now okay, so these are the bitwise operator, the first three. Okay, now if I have x percentage equals to 3, so the value of x should be 0. Yeah. So if I see 8, let's check the value of decimal to binary. The value of 8 should be 1000, है ना, 1000, and value of 3 is 11. Now like we discussed, and operation, so 0 1 0 0 1 0 0 0 0 0 1 0, yeah, and this should be, the decimal should be 0. So this makes sense, right? Now next is, now the value of x became 0. Let's change it to something, let's change it to x again, 8 again, so that we have a bit easy. So let's do x, yeah, same. Okay, now okay, yeah, 8 over 3, so we know this, so 0 1, okay, 1 0 0, 0 1 1 1 0 1. Okay, let's quickly verify 1 0 1 1, binary to decimal. It should be 11, right? Okay, let's again, let's keep it to 11 here. Now let's do again x, what's left, yeah, this one. Okay, okay, so now let's do this, and it should give me x, okay, let's see how it works. So we have, okay, so we have x should be 11, right? Eleven equals to 11 11 to the equals to 3. Now it should be, it should be 8, right? Yeah, so if I print it, it should be 8. Okay, what next? We have left with these 3. Let's quickly go through these 3 as well. Again, bitwise operator, bitwise operator. Okay, okay, just for the purpose of like testing, okay, let's do it. So for example, we have something like this. Okay, so right now we have value of x as 8, है ना? Yeah, so 8 x equals to 8. Now let's quickly check how we can write 8 in decimal to binary. 8 goes here and this is how we can write it. Okay, now let's move the letters quickly. So 0 0 0 0 will move on 0 0 0 0. Yeah, next we will zero, and next we will move. Yeah. Now let's quickly see the value here. Binary to decimal, it should be 64. Let's quickly verify 64. है ना? Okay, let's check the next one, which is now the value becomes 64. So 64 3. Okay, so let's check what is 64 called. Decimal to binary. First of all, we need to check what is 64 called. It is, okay, I think it will be the same, but let's do this. Zero 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 1. Like we are just reversing it, right? So 1 0 here. Now if we quickly verify it, this is same as this, so output should be 8. Okay, I haven't printed it. So print x and the output would be 8, right? Because we are just reversing it. Okay, next is print x equals to 3. It's simple, it's 3, right? This, like, it is can be written as x equals to 3, then print x. Okay, we are just simply printing the value. Okay, so these are the operators that we have discussed. Then one last thing which is left is the operator precedence. Okay, so right now what we have discussed a lot of operators. So for example, someone gives you something like this: print print 6 plus 4 plus 9, 6 plus 5 minus 10 into 4 divided by 7, 5, let's say. So how should I do it? If I move left to right, 6 plus 5 11, 11 minus 10 into 4 divided by 5. So then I'll do 1 into 4 divided by 5. If I do 1 into 4 divided by 4, it should be 0 or something like that, 0 point something or something like that. Yeah, let's check it. It is giving me 3. And why is that? Is because of the precedence. Okay, if you remember, in school you guys must have like learned something like which is called as board mass. is called as board mass or something along the way. You guys must have read it. So basically multiplication, division, addition and subtraction. So now let's follow this and calculate. So first of all, what I should do out of all these operations is the multiplication one. So if I say 6 plus 5 minus 40 divided by 5, next I should do the division one. Yeah. 6 plus 5 minus 5 hits a 40, right? Next what I should do is the addition. 6 plus 5 equals to 11. 11 minus 8, yeah. Now 8, 9, 10, 11, 3, right? And the answer is 3. So how it is working? So we have a operator precedence. So right now I have just used the arithmetic operators. What if there is exponent is there? What if the logical operators or the comparison or the identity operators are there? Then how should the operator precedence work? Okay, so what you can do is you can just simply copy it and you can put it in your Google somewhere and it will show you the precedence. Okay, so this is how the precedence work, and this is very important and it's getting used like almost everywhere, because otherwise your calculation will mess up if you don't follow the operator precedence. Okay, something, if you read here the precedence, it says that plus minus is on the same. Okay, so if it is on the same, then how it should work? So for example, if I am writing something like print 5 plus 8 minus 2 plus 5. So if you see here, so plus minus, this is on the same precedence level. So if the precedence level is same, then you should go from left to right evaluations case of that. So here it should be 5 plus 8, 13. 13 minus 2 plus 5 should be 11. 11 plus 5 equals to 16. So let's quickly verify it. It should be 16, right? So this is how you can work with the operators. I hope this clears a lot of things, because I think it was a pretty lengthy one, but I think it all makes sense, and I'll see you in the next session.